of the day. AiiDA. As alluded to frequently up until this point, the problem that we're solving is the historical record of what you have run with your workflow manager over the entire course of things. Where did your inputs come from? What commands ran them? What versions of software were used? What was run after that? How do all of the pieces actually chain together inside your pipeline? For sharing information with other members of your team, with collaborators, with your funding managers, whoever else you may need to convince and explain about what your work actually did. So the extra layer that AiiDA is adding is a graph that keeps track of not just your pipeline and the state of your pipeline now, but the state of everything that your pipeline has been used to do in the past as a historic record, and tools to query and visualize and share information about that history. So the cultural background here is materials science. Yep, okay. And we've got this provenance graph. So, what do we mean specifically? So there's a decorator, this task.count function. Oh, is that sound getting in here?
Yeah.
Well, there's nothing we can do about the popular music playing out in the hall, I'm sorry. So this decorator is under the hood by AiiDA, adding recording infrastructure to preserve inputs, outputs, and what functions are being run. That information gets put into nodes in a graph database, or a database graph, actually. I don't think it's a real graph database. I think it's links in. Well, we're using SQLite in the example, and Postgres would be standard. So it's not a graph database. So calculations have links to the inputs and outputs related to them. And this is shaped like a directed acyclic graph, but this is a historical record, not a plan or a current state. And the traversal of this information can happen in any direction. You can pick a result and you can query all of the steps that were used to generate this result, all of the inputs, all of the commands, everything. Or you can start with an input and you can say, show me all of the results that had this input somewhere in their ancestry. All right, so are you writing papers and publications that need this kind of high confidence, highly reliable information about your computational process? Are you doing work on projects that is lasting very long time? You want it to survive staff turnovers and quarterly reports and so on and so forth. We're still able to cache identical calculations as was possible with some of the other tools. It's helpful for sharing history and work of what was done between teams. It's easy to generate audit trails for validation and diagnostic purposes. So if you find that you have a faulty result, you can get all of the information you need to trace back to the exact origin of the fault that caused that result with this tool. And reasons not to move up to a more complex tool. Do you not need that long-term storage? Or are you just running a one-off thing and then you'll have the end and you don't need to communicate how it was produced? There's extra storage overhead with keeping this information around. You might be subject to data quotas of some sort that limit the amount of storage that you can devote to all of this historical information. All right, and some discussion of the training examples that we're going to use now versus how you would do this in production for real. So this Verdi Presto command line interface that is described in the example documentation. This is using SQLite, which is a file system-based SQL interface and localhost. Things can get started and be prepared in less than a minute. We're not using the Postgres, and we're not using the RabbitMQ, and we're not using the AiiDA daemon process. Those things, if you were doing production, are things that you would want to be running in Spin. The workflows that we're running in the example, we're using this WG run. Architecturally, that is shaped basically like Maestro. It's a process, all of the information is in the process. It's going to talk to the SQLite. But if that process goes, then the state of your workflow, that goes too. So if you were running things in production instead of with this quick SQLite, then you would be using submit instead of run, and that's the asynchronous way of injecting workflows information into this ecosystem. And it submits it, and the actual AiiDA daemon and those other pieces of infrastructure are what would take care of the workflow after the submission. You should be putting these things in Spin for production, and you might also want to be using SF API in some regard for the connections between Spin and Perlmutter. This is not a Spin or SF API tutorial. We don't have a week. And actually using the provenance model, like so many other things, the access is through Python API primarily. And there's some command line, those Verdi Presto tools also have some visibility into this. That portion of the interface is the same whether you're using the training setup or the production setup. You don't have to learn a new set of tools for exploring the provenance when you upgrade to production. Okay, so moving up to the first example, you add the task.calc function decorator to your Python function, and that is the sign and entryway for AiiDA to do all of the information extracting that it needs to do. Your function is the same. Everything it does is the same. All of the stuff is behind the scenes and automated for pulling out that information and preserving it. You are forced to use in your inputs and outputs these ORM int float dict string, these other types. That bit of wrapper is needed for AiiDA to successfully access and record these things. All right, and the example workflow has 3 calculations with this task calc function decorator. We've got prepare data with a parameter, so it's going to multiply it by 2 and return an int. Like these are just, take a number and change something about it and return it in a sequence. We've got a compute, it's doing a square, and we've got an analyze that just does another integer transform. Although this one is, instead of returning an integer, it's going to be a dictionary with the result and also a status. So inside your Python script where you're setting up to use AiiDA, you have this work graph call, you give it a name that gives you the container that is going to be holding all of this record information. You add your functions to it, you include its name, its argument. You do a little bit of wiring to pipe your outputs and your inputs together between tasks. So prep, inputs, results. And the word graph operating this is smart enough to know that you can't actually run things until their dependencies are satisfied. Okay, and load profile is the part that actually sets up the connection between your script and its operation and the AiiDA database behind the scenes that is permanently recording all of the provenance information. Then you do your work graph.run. This is the synchronous version versus submit, which is the asynchronous version. And that's going to actually set running the pipeline in motion. In the storage of information by AiiDA, every node in the record graph has this primary key, and it's a human readable number, and it auto increments when that node gets a new piece of information. So every time you have like a new pipeline that runs through a run of analyze or generate or whatever, it's going to get a new primary key to uniquely represent that additional time it was run. And when you're using tools to actually explore, view, look at the data from the record database, the primary key is the piece of information that you need to actually uniquely identify, like if you're looking for a specific run from a specific task. Once you've got your script with your AiiDA ornamentation run, you can use these Verity tools to go into the records and actually give information about the state. So Verity process list all. That is going to show you everything in there with no filtering, just the entire list, all the primary keys of all the pipeline pieces. You can use process show to just look at a single pipeline piece. Then it's like, okay, well, what was the input? What was the output? Is it pending? Did it run? Did it fail? How long did it take? This node graph generate piece, that is a visualization. So that is going to give you a file. The default is PDF, but I changed it to PNG because that's easier to open up in like Jupyter Hub or something like that. So you're actually now able to draw images of the graph structure of the history of running your pipeline. And this can be done to the point that like, this might be an image that you want to include in a publication as a demonstration for something that you ran. And there, there's a language to the image generated where rectangles represent data nodes, ellipses represent process nodes, and the arrows are the links between provenance, input, output. This was used to generate that. The actual behavior of these things is the same on SQLite and if you were running the Postgres behind the scenes. And the example with its 3 steps, we're gonna end up with less than 15 provenance nodes. So in the example, once you run the graph generate and open up the PNG file, you will see the visual representation of the run of that instance of the pipeline. Okay, query builder. So the easiest and most accessible way to look into that is the command line interface, but you're a human typing things on the terminal prompt, you have a limited capacity to do that. Query builder is the interface for writing programmatic tools to do that for you if you want more information and then to aggregate it somehow. If you're looking for a needle in a haystack and doing a search kind of thing, Query Builder puts together a query into that database, and you can be chaining together these different Query Builder features to sort of widen or narrow or filter or specify or whatever you need or desire to get out of these provenance records. So this the basic query builder example. You're starting with your record, and then you add this dot append. Which node types do you want to see? Filters for what characteristics of those node types do you want to pull out? Do you want to pull out a number that's how many nodes match the query? Do you want to program a loop that will iterate through each instance of what the query builder finds with this query and do something unique to each one? Again, the API is the same regardless of what the backend is. And you've got access to the workflow nodes, different instances of running the workflow, the calc function nodes, different pieces inside your pipeline, and data in the form of you want integers, you want dictionaries, you want floats, you want strings. You can query based on the time that things happened. You can query looking for specific values, and you can query looking for specific links. All of this stuff has been recorded automatically behind the scenes by AiiDA. If you ran something with AiiDA 6 months ago, this information is available to you as long as you kept the database around. So you can put in filters for your values and do something specific that's shaped like this. All of your int nodes with value 42. You can find all of the processes by chaining something together with that. Find all of the downstream things that use that specific piece of data. And you can follow links through your workflow history programmatically. Like you're stepping through a graph. Investigate every node that is incoming to this node. Investigate every node that is outgoing to this node. Do a depth first search or a breadth first search. And so this is the way that you put something together programmatically if you want information like, this is the result that I care about for some reason. Find me every input that went into generating that result. Or this is an input that I later found out was faulty or corrupted somehow. I need to generate the list of all of the outputs that are downstream of that in history so that I can, rerun them or remove them from consideration somehow. Yeah. Follow incoming links, follow outgoing links. Query Builder components can be composed together. You can mix up your filters and your traversals and do, however many combinations of specific things that you need to do to pick out exactly what you want from the history. Okay, and the power of being able to write these queries into the database is the main thing that you get from the provenance database relative to, say, trying to dig through the records that Merlin leaves behind after a run. It would totally be technically possible to write a Python script to dig through Merlin records, but it's probably going to be a lot more work than having access to query builder tools to go into it. Okay, so we already mentioned the node graph generate, and the third example is going to give you an instance of actually using that. Ancestor depth 999, like just show me everything that went into how this result was produced. Descendant depth, that's how you give it specification in the other direction. You can export these archives, so you can create an archive of all the nodes with the personal with a primary key for my workflow.AiiDA. You can create the full archive. And these archives are created by AiiDA in a way that is completely self-contained. All of the data is in there, all of the process is in there, all of the links between nodes are in there. Everything that you need to pass off to fully explain the history of the work is available in the archives. And that viewer can take that archive, use their own AiiDA infrastructure, and they can run all of the same queries or their own query on the same thing. All right, and on the subject of the difference between the example deployment and a production deployment, again, I'll repeat, run is for local, it's synchronous, it's short-lived, and we're using SQLite. Submit is the long-term equivalent to that. It's going to start a daemon. It's going to give you a new primary key to this is the starting point of the workflow that you just ran, and the daemon running AiiDA is going to take over from that point. And that's how you run long HPC campaigns and trigger auto resubmission and concurrent workflows and that stuff. The code change from moving to short form to long form is minimal. Replace run with submit. The provenance behavior of both of those is the same. Anything that you want to make sure that works in production, you can try out inside run on a small toy version. And it's time to upgrade when you're adding multiple users, your campaign duration is getting very long, and similar to the Merlin concern, if you have lots of tasks, you're doing high throughput, and your single coordinator process has become the bottleneck for how reliably, how many tasks it can organize at a point in time.